Alright, let's get this thing up and running on Emulate. So the first thing we need to do, we've laid out a lot of logic. Let's come up here to Logic, Verify, and verify the entire controller. And I don't see any errors appearing, so that's probably a very good thing. We can go ahead and save this project. And I have got my handy emulator running right here. This is what RSLogix Emulate 5000 looks like. It looks a little more interesting because it can simulate modules and things like that, but in reality it's additional complexity above and beyond the 500 emulator and very minimal benefits, so I'm not a fan. Plus, when you try to change things and move the controller around to different slots, it's a royal pain. I mean, it really, you have to struggle with it. So I'm not a fan of this emulator at all, but it does get the job done. So let's come up to here, Communications, Who Active, and we're going to come into our AB VPB, and we're going to select our 5000 emulator, and we're going to set the project path. So now we've defined where our project actually is going to live. Let's go ahead and download that, and it'll take one more check to see if we've got any errors, and assuming we don't, it'll go ahead and download, and now we're in remote program mode. So now we can go ahead and start interacting with this thing. Let's put it into run mode, hit yes, and nothing happens, which is exactly what we wanted. So right now our system is off, and you can see that our state is set to 0. But I want us to be running. So let's go ahead and toggle our start button. And that's put us into mode 1. And then after 5 seconds we went into mode 4. So why did that happen? Let's come down here and check. Mode 4 is our low alarm mode. And we know we haven't closed any of our level switches yet. So right now it's saying, hey, we've got a problem because we were trying to run, but there's nothing in the tank. So we come down here, we can see, sure enough, our low switch is open. So let's go ahead and close that low switch. So I'm going to just toggle that, and that alleviates the condition, but of course it doesn't reset the alarm. To reset the alarm, I need to actually hit alarm reset. So let's come over here and toggle that momentarily, which should put us back into mode 1, and then it should detect where we are. Now it says, well, we're not low, but we are low, so it puts us into mode 2, and mode 2 is our fill mode. So now our tank is filling, and that is exactly what we want. Now it's going to keep filling up until we get to the full level switch closing. And let's go ahead and take our high, and where is our high level switch? That's what we want to actually actuate. So here's our high switch. Let's go ahead and toggle that, and after 5 seconds we should go into mode 3, which we just did. So now we're draining again, and once we start draining, it shouldn't be too long before that high switch opens again. So let's toggle that once more, and now we're somewhere between the low level and the high level, but you notice our mode doesn't change because we're not down to low yet. Once we get down to low, then this switch is going to open again, and once it does, we're going to watch and see, and our state should change back into 2. It didn't, and that's actually because, you know what? Whenever we were going through it a second ago, I actually didn't close the switch when I was supposed to. So if I energize that, yeah, now we see this thing actually starts running up, and we see that our mode switches to 2. So it's not a bug, it was just me simulating this thing incorrectly. But now we're in the right mode, we're going up, but let's say we keep going up and we go up too high. So let's come down here and close our high switch. So we toggle that, and now sure enough we go into mode 3, and mode 3 is our drain. But let's pretend that for some reason our valve's stuck, our pump's still on, we keep going, and we end up closing the high switch as well. And after 5 seconds we can see our state is going to change. Now we're in mode 5. When we come down here, we see that an alarm exists. We're in high alarm mode, and both our pump and our valve are disabled. So we can come back up here and let's alleviate that. Let's change our levels. So we're going to say our high is no longer closed. We're going to say our high switch is no longer closed. We're going to say that our low switch stays exactly where it's at. And then let's come up here and hit the alarm reset button. So we're going to toggle that and then immediately toggle it back. We go back into state 1, and then after 5 seconds we go into state 2. And now I say I'm tired of running this thing, so I hit my stop button. Now we're in state 0, and when we scroll down we shouldn't have anything running. So that looks good. I would say at this point we have a functional system. The only thing that we could do differently is we could have an override button on low, or maybe a hand-off auto control on our pump and valve, which allow us to fill the tank up to a certain level so that whenever we get into a low condition, we have a way of refilling it. Otherwise, we'll never go into fill mode. So we could do more things, and we could certainly make this program much more robust and much more functional. But at this point, we've got one ladder diagram which controls the whole system. I've basically proven the concept that you can do this whole thing, and there are more elegant solutions. This is a very basic solution, but I did that whole thing in 20 rungs, and that's with multiple alarms, multiple devices, 4 different levels, and I could have added in an analog level at this point if I wanted to, with scaling and things like that. That would have taken up another, 2 or 3 rungs, but this is what we can do with ladder logic. In one program file, we can write that entire program, have it all working. I can go through and put in rung comments every step of the way, which explain exactly what's happening on each rung. Somebody can look and see all the details, see what every single bit and every single integer value is, but what we cannot see is actually how the process is flowing. We can't see easily what state we're in. We have to look at the value of a state int and then try to remember what it was, or look at the comment that I voluntarily put in that describes where we're at. Something that I can do if I wanted to make this a little bit easier on us all, I can go up here and edit state int properties, and I can put something like 0 equals off, 1 equals standby. That's not supposed to be 2, that's supposed to be 1. Here we go. 2 equals fill. 3 equals drain. Not drain, but drain. 4 equals low. And 5 equals high. So I can put that description in there. And now you'll see, that pops up here, but that's still not the same as being able to see a map of the machine's states in something, like a diagram or a more graphical format. Now we still have to read text, to see what the machine's doing. We have to scroll up and down. I want to know what the pump is doing. I have to come down here and look at pump. I want to see what state my switches are in. I have to come up here and look at the state of the switches. So you've got all the information, but then just imagine if I've actually written this program the way I usually write a larger program. I have one ladder which has got my, analog inputs. I have another ladder for analog outputs. I have another ladder for, control. I have another ladder to manage the machine's state. I have another ladder which has my alarms. If I have a lot of alarms, I might break alarms down into analog alarms and digital alarms. So, I can have easily 10, 20, 30 ladders all working together in one single program. And when you're watching the machine run and you're trying to go through the program and troubleshoot and visualize and see what's happening on a high level, it can be impossible using ladder logic. I mean, you really have to know the program intrinsically, know where everything is, know what to look at to kind of see what that's doing. And, there's a lot of navigation. There's a lot of running back and forth. It's really, really just hard to get a bird's eye view. So now that we've kind of gone through ladder logic, we've had not only a refresher course, but also a reminder of what ladders are good for. They can do everything, but also what ladders are kind of bad at. They don't really give you the big picture. Now we're going to reapproach this same system, and we're going to incorporate these other paradigms, and we're going to see what those can do for us, what they can add to the equation. So I'll see you in the next lecture.